Hello, I am Ahmad Yacouby, and I will be teaching risk, reliability, and integrity of offshore structure. So let us begin with the structural design principles. Offshore structures, as we can see here, consist of offshore oil and gas platform and offshore wind turbine. So these platforms are a special type of complex structure. So the offshore oil and gas platforms are normally large-scale structures which are located or fixed, which are located into the seabed. So normally they are designed to accommodate the facilities and the equipment to drill, extract, and also process oil and gas. So let us have a look into the overview of platforms. So the platform can broadly be classified into two categories. We have the bottom supported structure, which consists of jacket platform, gravity-based structures. We have the jack up, and also we have the compliant. The floating platform consists of FPSOs, floating production storage, and offloading. We have the semi-submersible, we have the TLP, we have the spark platforms, and the FLNG, and offloading carriers. The operational water depths of the different type of platform vary depending on the location and also depending on their type. So fixed platform can only operate in shallow water, while floating platform can operate in deep ocean. So what do you mean by classification of water depth? This is the simple classification of water depth. So if the platform is located in shallow water, that means it is in a water depth which is not exceeding 300 meters. In deep water, mean the platform is within 1,500 meters, and ultra deep water is a location where the platform is operating in water depths exceeding 1,500 meters. So practically speaking, offshore platforms are a specific type of structure. This is because they are unique in their design, as we have seen in the previous slide, and also they are unique in their function, or we call it in their functionality. This is because they are site-specific requirement structures, not like building, where we can see the shape or maybe the orientation and the method of constructing buildings are almost similar. Also, the way we design and construct the bridges is also similar. But when it comes to offshore platforms, they are actually unique in their design and also unique in their functionality. This is the reason why design of platform is really a complex task. So to make sure that these platforms are safe, designers need to take into the consideration the effect of wave, the effect of current, the effect of accidental load. And they need to understand the basic concept of wave motions, as well as the design load to be taken into account. So the fundamental design requirements for offshore platform is that they should perform adequately under all expected actions, considering the environmental load and the accidental load. In addition to that, if these complex platforms are subjected to fire event, for example, or subjected to explosions or to impact load, then these platforms are not supposed to fail. So the design should be considered in such a way that when an event of fire or in event of explosion, the platform is not damaged. So the appropriate degree of reliability that should be taken into account is that the consequence of failure need to be reduced, and at the same time, the level of reliability need to be increased. And this is what we are going to cover in this course. Okay. As offshore platforms are unique structure, and what makes the offshore platform unique is their design requirements as well as their functionality. So it is important to understand the deterministic design approach as well as the probabilistic design approach, including the mode failures and also the treatment of human and gross errors. Deterministic design assessment. This is one of the design methods in which the relationship between the input parameter and the output parameters are well determined. And a good example is design by geometry, in which the ratio between the length and the width can be used to come up with appropriate design, or the load factor design, in which appropriate factor of safety is taken in order to increase the load by a well-defined factor of safety, and by reducing the strength by using appropriate factor of safety to consider accidental load or geometric imperfection or imperfection in the material itself. Deterministic design method also include the allowable stress design, which is based on the linear elastic theory, right? And the well-known linear elastic theories involve Euler theory in 1757. We have the column theory, Navier-Stokes, Saint-Venant theory. We have the Morse theories. We have the Castigliano, Timoshenko, and so on. So these are all related to the allowable stress design, which is one of the deterministic design approach. The deterministic design approach also includes the limit state design, which can be broadly classified into working stress design and load resistance factor design. So in the deterministic reliability method, we use appropriate factor of safety in order to ensure that the uncertainty in the load is taken into account, and also uncertainty into the strength of the material is also taken into account. But this deterministic method has some disadvantages, as you can see here. And the most important disadvantages to be considered is the properties and partial safety factors which are being used in the deterministic method are often not the best estimate. Right? In addition to that, we have the risk of failure or collapse, or the overloads which are necessary to cause a failure of collapse are not unique, mean they may vary widely for different structures. So therefore, now there is new approach in the design, call it probabilistic design approach. And this probabilistic design approach is normally used in the oil and gas industry to take into account the uncertainties associated with the material, uncertainties associated with the method of selection of the sampling during the testing process, and also uncertainties associated with human errors. Right? So here we can see a simple comparison between deterministic design approach and the probabilistic design approach. So as I have mentioned it earlier, in the deterministic design approach, the variability in load and strength parameters, including the model uncertainties, are included in the safety factors only. While in in the probabilistic methods, the stochastic nature of the load and also uncertainties involved in the material and also uncertainties associated with the method of sampling, uncertainties in the model are directly in the probabilistic modeling equations. Then we are going to discuss the mode of failure as well. And the importance of mode of failure in a structure is that an offshore structure consists of complex geometry, including the loads, including the environmental load and also the material. So therefore, it is essential to understand the mode of failure. What does this mean? This means if one of the tubular member fail due to corrosion or due to accidental load, then what would be the overall mode of failure? Well, when we talk about mode of failure, the basic variable that may affect the mode of failure could be the geometric parameters, the material parameters, mainly the Young's modulus, the fracture toughness, and so on. We also have the corrosion, which may affect the mode of failure of offshore platforms. So all this will be discussed in details in this course. In addition to that, we will be discussing in details the treatment of gross or human errors. As we can see, the mode of failures of offshore structure can be broadly classified as technical failure. And a good example is when the load are underestimated. So if the failure is due to underestimated load, this can be an example for technical failure. A human error, and a human error can be again classified into two categories. We have the design error, which means during the design process itself, there is some human errors. Maybe the software used is not adequate, or the force and the load considered during the design are not appropriate. So this will lead to human errors. We also have fabrication error, which is a common in the construction industry. Well, a human error can be either deliberate acts, which mean acts associated with frauds, or the human error can be non-deliberate acts. And an example is inexperienced people, negligence, or maybe new material is being adopted, and so on. So all this will be falling under a human error. And as designer, you have to take all this into the consideration during the design process. Well, the main objective of this course is actually to understand the risk and come up with appropriate mitigation plan in such a way that failure or the risk of failure can be minimized. So here we can see example of incidents related to failure of offshore platforms. The first one is Alexander Keeland, which was recorded in 1980 in the North Sea. Then we have the Ocean Ranger flooding and capsizing. This was in 1982. Then we have the case of Piper Alpha in 1988 in the North Sea as well. This was a case of fire and explosion. Then we have a P-36 explosion, a flooding and capsizing, which was recorded in Brazil in 2001. Right? So, guys, that's all for now. And this is a very short introduction to risk, reliability, and integrity of offshore structure. So hopefully you enjoy this introductory lecture. So I would advise you to start reading more material related to this topic, and hopefully we will meet in the next lecture. Thank you very much.